Hi, we are the team number 11 and we are going to present our problem. And my team is conformed by
Itzel González.
And Raimundo Zárate.
and me, Luis David. Let's start.
Hello, we are going to talk about kinematics. So give me 1 second. Okay, our problem is about kinematics. Okay, so kinematics describes the motion in a line. So we need to use the x-axis that is here, and we need some points that we need to obtain from the problem and will help us to obtain the result and the question that the problem is asking for us. So the first thing that we need to have is the initial position, the final position, the initial velocity, the final velocity, the acceleration, and the time. These will be some of the things that will help us to, as I mentioned, to obtain the solution.
Okay, so now we are going to start with our problem. The problem says that a truck covers 49,664 meters while slowing in 4.2 seconds to stop. And as Raimundo said, we need to have our values. So our initial position is 0 meters. Our final position is 49,664 meters. We don't know the initial velocity, and our final velocity is 0 meters over seconds. We don't know the acceleration, and the time is 4.2 seconds.
Okay, the first thing we have to do is that we have to find the original speed in kilometers per hour. And we can do it by doing the following. First, we have to divide 664 between 1,000, sorry. 1,000 is equivalent to 1 kilometer, and this is equal to 0.0496. Then we have to divide 0.0496 between 9.2 between um, 3,600 and 3,600 is change. I change it into an hours because 1 hour have 3,600 seconds and 4.2 is the time, and the speed is distance over time. Then I divide it by 2, and that's how I arrive to the result.
Okay, so in this next option, we need to find the acceleration in meters per second squared. So the formula that we use is acceleration is equal to 2 times x divided by time squared. So when we substitute this, we're going to have acceleration is equal to 2 times 49,664, which is our position, or it can also be called our distance, divided by 4.2 squared. When we do this 49.64 times 2, we're going to have 99.328 divided by 4.2 squared, which is 17.64. If we divide these two results, we're going to have 5.6308. But as the truck or the car is declining, the acceleration needs to be negative or minus because the truck is going to stop. So the final result will be acceleration is equal to minus 5.631, 31 because we rounded up to the next number, and it's meter over seconds squared.
So here we are going to answer the question number 3, that is letter C. The question number C says, if the truck is initially traveling at a speed of 107 kilometers per hour, what is the distance in meters for the truck to stop, assuming the same rate of acceleration? The question letter D asks, how much will it take in seconds to the truck to stop considering its initial traveling, it's 107 kilometers per hour? So here we need to do one of the tables that we practice in our class. And we need to put the initial position, the final position, the initial velocity, the final velocity, the acceleration, and the time. So the problem gives us the initial velocity. First, we need to convert the kilometers per hour into meters per hour. So we obtain 29.7222. The seconds are 5. The seconds we don't have it. The initial velocity, the initial position is 0, sorry. And we need to find the final position. So the final velocity is 0 because we are now in all and everything is stopped. So it's 0. The acceleration is minus 5.63. So we need to use this formula that is final position, it's equal to initial position plus initial velocity times the time plus acceleration plus the time squared over 2. For that, we have these values and we need to put it here in the equation. So it's x that is 0, that we don't have it, sorry. X0, it's 0. BO, it's 29.7222 plus the time that we don't have it. So we first need to solve the equation of the time. For this, we will need the initial velocity and the acceleration. So we need to divide 29.7222 over minus 563. It's equal to the time. This gives a time of 5.279. With this, we can solve this equation. So we need to do the same procedure. We already have the time, and with this, we will obtain a result of 78.44, and this will be the result. So thank you for watching, and this is our problem of the exam. I think it was easy, but in some parts it was difficult to solve it. So thank you.